I wanted to show a video here how to protect firmware on the ESP32. This is a C3, and this is Arduino development system. You can't do firmware encryption through Arduino, and that's the preferred way to protect the firmware, especially if the flash is external, because somebody could just unsolder the flash and then copy the firmware. I tried doing it, I got it to work, but when I had firmware encryption enabled, Arduino started having compatibility issues with EEPROM read and EEPROM write, and also the little FS, little file system, and which I don't want to. I have a huge project here. I don't want to have to debug on why it's not working with code encryption. But if you want to encrypt it, the second half of this video, I show how to do that, but it wasn't going to work for me because my application. And a lot of people they port over to ExpressF IDF. That's going to be perfectly compatible, and Platform IO maybe could be compatible. But this video is for Arduino. So since Flash encryption doesn't work, the next best thing to do is just burn all your communication fuses that allow extraction of the code. So I'll have this in the description, just the fuses that you need to burn. You can get the exact fuse names if you're on a different chip because they change it. This is the V5 platform for the later chips, but it's pretty much the same. You're going to disable your YART download. Um, I'm disabling encryption. I don't probably have to do that, but I'm doing overkill here. Disabling download catch. Disabling being able to force download, basically disabling the button, the boot button. Disabling everything on the JTAG, the physical pins, um, USB, disabling the USB JTAG. I don't disable the serial port because I use it. I use a command line interface to actually run this for my production testing. I'll do a command that'll run this code to lock the chip when I want. So I keep the port open, but it's fine. You can't without the ROM allowing the download. They're not going to be able to do anything, and it's the ROM that actually does the download, not the bootloader. And then here I'm also disabling everything that has to do with the JTAG, which I don't even use. But basically, this is everything I could think of to disable access on the chip. And basically, you can develop your chip, program it, and then run the code, lock the fuses, and then confirm when you're locked. And this will be in the, what you do is try to read something from the chip. I'll have this in the description too. So I try to run the command, make sure there's the right COM port, just to read the EFUSEs. So at first, when my application's running, it says wrong boot mode detected because it's not even letting it go into the boot mode. And then when I hold the button to try to enable the boot mode and then run it again, it crashes out. It can't read because the chip is locked. And that's it. Just disable access. Now, you're going to have to use over-the-air updates for changing any firmware on your chip now, because you're not going to be able to download either. If I try running, I'll get the same error. And this Arduino is actually using the ESP IDF commands, but they have them where it's you can't do the flash encryption. And there's actually flash encryption does slow down your application 5 to 10%, more so in certain areas. Uh, and so this is not a bad way to do it. And you're good to go as long as your flash is on the same die. Nobody's going to get your code easily. They would have to decap. They'd have to use a microscope to try to attach pins, and that's not going to happen. So I hope you like watching the video. And if you want to see how to do flash encryption, just keep watching. This video is for all the Arduino guys using ESP32 and they want to go to production. They want to protect the firmware, but it's just a mess out there. AI doesn't really know what to do. I spent a week on this thing. Find one other guy who put a little website out, but he's not even doing release mode. He's just going to production with developer mode, which is somewhat protected, but not totally protected. So ExpressF, it's like their stuff seems really complicated. They make it easy for their development system. Well, Arduino won't protect your code, and porting over. I mean, I got a huge app. I do not want to port it over to the ExpressF development system. So I found a way that basically all you got to do change your bootloader, and you can get the release bootloader, and everything will be protected. So on your Arduino project, make sure you set your show verbose output on the upload so you can get your command. That's going to tell you where all your files are. So I already stored my command right here from my Arduino, and here's where all the files that Arduino creates. It actually has an ESP32 IDF in Arduino, but it's creating them. And what I need is a different bootloader, and the bootloader has to fit within that 8,000, because if you start moving, you're using a custom partition table, then you got more headaches. It's easier to just, Arduino's like super simple, just using everything canned in there. So basically in this video, I'm going to show you how to get the production encrypting bootloader, how to create that just by making a sample project. And then once you have that created, you just swap your production, just swap your bootloader out. It'll take, after it uploads, it spends an additional 30 seconds encrypting and locking down, and it takes care of all the security fuses for you. And just like as if you were an ExpressF developer using their software. So I made a document, it's in the description, and it's a step-by-step where it shows everything. So first, for reference here, my project's called Device Away, and it's in a folder called Device Away. And then I have a production testing software, which that's all automated, but it's using the same command line, the ESP command lines that I'll be showing in this video. But I'm putting all my firmware into this directory, into my tester, and then there's a directory for that. So this video is going to show you how to manually do it. You can easily automate this. So step one, we want to open up Express IDF, which I'll just close it. I already had it open there. So first you got to install it. There's lots of videos to install it, and this is version 5.3. And so this is the development environment, which if you weren't using Arduino, you'd be working command line and working here, but it's a lot harder to use it. All we're going to do is create a little project that doesn't have any code in it, and we're just going to be grabbing the bootloader from it. So next we want to go to you want to create a directory for your project. So here's my Arduino project, which is huge. And then I created this little encrypted, actually I had AI help me create it. There's like one command to create a project. I'm not showing it in this video, but it's pretty simple. So I want to change to that project directory. Let's go to there. And then you want to set your target processor that you're using. And then here's where you do your setup for set your configuration. It's a nice little, instead of doing it in the actual file, it gives you a little menu system. So let's go ahead and run that. And then I show you, so your project settings would all be in here. And I show you what to set. Let's put this on the side and put this over here. So here's where you're setting your release stuff. So on your bootloader, use your down arrow key. You set your verbosity. This makes the bootloader smaller because if you go over 32K, which is what the encryption kicks up the size of that bootloader because it's actually encrypting itself and your firmware. So setting a verbosity just to show errors, that's fine. You can even make it smaller if you turn it completely. You could go to no output, but it's like only 28K with this, which is about the same as the Arduino bootloader. So you set your verbosity, check enable flash encryption on boot. That's under security features. Let me hit escape. Oh, make sure whenever you do, make sure you hit S to save anytime you do a setting. So you go to security features. Here's where you're turning on your encryption on boot, and it's actually giving more code to the bootloader. I spent a lot of time seeing how the bootloader changes by looking at some hex compare, comparing, when I do a change here to what it does to the bootloader. So just do all these settings. So we want to enable flash encryption on boot. Make sure you do release, because the only other thing I found on the internet, the guy he was doing development, which it's telling it was not secure. So you make sure you're on release. Uncheck. This is like a time saver for small apps. I uncheck it because I'm using all my memory. I'm just going to encrypt the entire partition and then check flash encryption enabled on app startup. And so this is going to require flash encryption on startup. And then make sure you hit save on that. And then a couple other things, set your flash size just to get it to compile for you to match your chip. That's under serial flasher config, go down, set your flash size. Now here's really important. The bootloader has to know where the partition table is. So Arduino's 8000. That's why we're making the bootloader smaller so that it fits in the 8000. I spent a week moving the custom partitions. That was such a pain. It wasn't worth it. I'm redoing this video just to show what actually works and spare you all the heartache. So we got everything set up on there. We saved it. So now we're going to build our project. So I'm going to just hit the build command, and I'm in the directory of the project. Notice I don't have any code at all. I'm just building it with there's nothing in the loop because I don't care about the code. All I care about is the bootloader. I don't even care about the partition table. I just care where the partition table is started. You might hear my dog running around. Okay, so next I want to copy the bin to my production firmware directory. Now, it also gives you a little sample right here. So it says it's completed, and it says, oh, if you want to flash it, which it's not going to do anything, so there's no point of flashing it. It gives you a little sample there. And notice it's kind of similar where my partition table is. I just copied and pasted it. But I'm using, well, I'll show you the command for burning it. Okay, so next we want to copy over our new bootloader to our production directory. So when you're in the encrypted project, it's under build, it's under bootloader, and then it's the bin file. Now, the bin will probably be the current time, but if there's no changes, it doesn't change it. But anyway, so you just copy that and then you paste that to your firmware, which I already did. So here's my ESP. This is my production encryption bootloader. And then here's from, you want to copy, well, don't jump ahead here. And then it's just saying compile in Arduino. You're going to get the command to burn in Arduino. And this is for development. You don't care about encryption because you're just doing prototypes. But you want to get all those files, your other files, you want to copy those over to your production directory. Which I've already done. I showed you that. So now I want to change my command prompt. I want to change that to my production directory. So here's my production. These are for automation for my testing. You don't need that. You could just have these files there. So let's grab that directory. Let's change my command prompt over, cd, go there. Clear my screen, CLS. Okay, so now we're ready to burn. So you want to know what your COM port is. I use Arduino for that. Now I got a fresh, just as $4 little board. I don't want to burn my production boards showing this demo. And so you want to make sure you got your serial port, COM25. And we're hooked up. So now I made the command here. We're combining our Arduino and our production bootloader. So you want to stick that here. Control V, hit enter. And so now it's flashing unencrypted. You know, nothing's encrypted yet. It's flashing it to the chip. So it did a hard reset because on the command, we're doing a hard reset. And then while it's hard resetting, now it's actually encrypting itself and it's locking itself. It's setting all the security fuses that it needs to set. So now let's see if my code is actually running. So let's go I just want a serial monitor here. So I'm going back to Arduino. Let's see what our output is. And there we go. Yep, yeah, this is my code stuff. Now these units aren't tested yet. That's why they're just unhappy right now. But my code's running. And then now to confirm that the chip is locked, all you have to do is, it's two places you have to check. Let's go back to my document. Is look at the fuses. Now I'm also going to be burning more security fuses. I'm gonna make the thing super hard. But right now we're good enough where nobody can copy your code. And I got my port in use. Okay, close my serial monitor. So let's see our security fuses. Let's get those out of the chip. And what we're looking for is that we have an encryption key burn. That's what that means when it's question marks, because it will not show you the key. Actually, nobody can see the key, even if they hack the chip apart. That's the key to their protecting it. And that way you can have external flash chips and they're protected. Also, this key is randomly generated when that bootloader first runs. So every device will have a different key. So we have our key 0 programmed. And then the other bit is that your encryption counter is maxed out. It's at 3. Your encryption counter is at 3, 1, 1, 1. So that's what release mode did, is it went ahead and burned all 3 of those. and the bootloader will not encrypt anything else. And then it's done a few more things. It's preventing downloads. Yeah, or preventing. It's doing all the release stuff that ExpressF recommends, basically. So this chip now is programmed and it's secured. So my over-the-air updates, those are encrypted. They're going to be a different pass, a different key, not a random key, because this will do a random key. Every single chip is going to have its own key, and you won't be able to get the code out. Now the C3 has the flash in the same die, but for external ones, this is even more important. But I'm protected, and it's actually painless if you just follow the video. And you don't have to change your bootloader. You can keep using that over and over, yeah, even when you do firmware changes. Or if you do have to change it in the future, you're going to get a new version of ESP-IDF and update that. So that's it. It's not that complicated. When you get it right, everything lines up and it works. I hope you like watching the video. Thanks for watching.